So I just thought today I'd try and do a better video about the IMA control. I've got it on the bench because I've just been tidying it up a bit, ready for some testing later on. I've got some deliveries to do. So basically, obviously, the prototype we've got in this box here, and this is just powered on the bench for testing at the moment. I'll explain the parts in that in a minute. So this goes into the IMA harness. Now I had some harness connectors, so I've made a pass-through connector. But in in use with the production version, you'll basically just have to splice into your harness. It's only 6 or 8 wires, I think it is, power, ground, IMACAN in and out. And if you want the FCAN as well, if you want that extra information, and that's just a splice. So yeah, so it's about 8 wires. You just have to find the harness somewhere between the ECM at the front, which is this connection here, and the IMA at the back. Now you might want to install it at the back, or you might want to install it at the front. It's probably best to install it at the front and bring the wires to somewhere on the dash, because the production one will actually have 3 buttons on the front and a couple of LEDs as well, so that probably needs to go somewhere near the front. And then of course you have the joystick, which connects to the module, and you also have the video, which you can see running here. So this is a smaller version of that screen. It's basically one of these. It's just a cheap $10 rear view camera setup screen, and these are absolutely great for this sort of application. Self-adhesive thing on the bottom, just basically whack it on top of your dashboard and you've got a nice neat little small screen. So this is not much bigger than a phone, to be honest, this one, and I'm using double-sized characters on the video here, and it's quite nice and readable even with my eyesight. So you can see it's chugging away, and it's just doing a test. It's just running, basically running. There's no IMA, obviously, signals coming in and out at the moment. So I'll just demonstrate the joystick. Well, you saw this earlier on in the car, but now I've got the proportional control working. So if I press it slowly, you'll see the x-axis changes if I go to the right, and if I go to the left, it goes down. If I go up, it goes down. Sorry, if I go down, that goes up. So assist is going to be to the right, regen is to the left, proportional. If you just whack it right over, you get instant full assist. And then up and down will be stepped assist and regen, but I haven't done those yet. And press the button, that operates that button there. So basically you can see it's chugging around. So that's the joystick. As I said, that's that nicely neat little 3D printed unit. So let's talk a bit more about the video and the board itself. So the video, as I mentioned, is just an RCA. This is a composite output RCA compatible video signal. So if you've got a head unit, etc., which quite a lot of these cars have, then you should be able to just plug it into a vacant RCA connector, and you should be able to display the signal on your screen. Now we can set up the video for PAL or NTSC video standards, but basically you're going to end up with a screen like this, which you can presumably select from your infotainment system with the video head unit in your car, or you can buy one of these $10 things and just have a dedicated screen somewhere in the corner of your dashboard, which is what I'll be doing. So let's have a look at the circuit. I'll just try and explain a bit more of this in detail. I'm just going to try and move this in a bit now, because I'm not going to show you the screen now. I'm just going to show you this. Okay, so what we've got, so from this side here, we've got it coming in. This is from the car, these bundle of wires here, and it comes in. This is the IMA CAN signal. It comes into this first CAN board. It's just like a line driver board, and then it goes into this PIC here, which is the slave PIC, and this basically just sends the message immediately to the master on the SPI bus. There's a fast SPI bus connecting these two together. And then the master is the one that's doing all the work. The slave is fairly dumb. That just receives and transmits messages from the master to the slave, from the slave to the master, and outputs or receives messages on the IMA CAN line to the ECM. So this is the ECM in here, into the slave, across to the master. And this is where the clever bit happens. This is where it then makes decisions based on whether you're pressing the joystick, etc., etc., and it then modifies the packets before sending them out here. And this one is out to the IMA at the back of the car. Now all the time there are signals coming in from the IMA as well, and all the time this is just receiving those, passing them to slave, and the slave is squirting them out to the ECM. And there's lots of different packets. I think there's about 11 different packets. 4 or 5 of those are coming from the ECM continuously, and 4 or 5 of those are coming from the IMA continuously, and basically they're being exchanged here and then sent out on the other half of the bus. And the master sitting in the middle does the clever bit, that modifies the packets depending on what we want with the joystick, and it sends out the data back to the IMA. Now this can also connect, well, eventually in the production one it will be able to connect to the FCAN line as well, so it'll be able to get information, data from the FCAN like speed and RPM and various other parameters that are available on the FCAN, and it can also obviously display those on the screen. This is the little video board here. Now this is sort of semi-commercial test version, so what I'm going to do, and what I've done successfully in the past, is I'm just going to actually incorporate that circuit onto the IMA manual control board. So the IMA manual control board will have the video output circuit, and that's a serial to video black and white driver. It's pretty basic, but it gives us a useful video capability, as you've seen, and it just drives a standard RCA video monitor. Now we drive that with a serial signal from the master at 57,600 bits per second, which is perfectly fast enough, and the master just sends out a byte at a time. Every time it's doing this loop, which you can see it's doing, it's checking if there's any data that needs to go out to the video, and then it's just sending it to the video chip. And it doesn't take any time really much for it to do that, because it's all done by separate modules in the PIC, and then the processor is not waiting around. We just have to load the video output with a byte, and it sends it in its own good time while we carry on doing the other processing. These are both running at 64 megahertz. Which is the maximum speed for these 18F PICs. The SPI bus is only running at 1 megahertz at the moment, and that's because this is a terrible rat's nest prototype. I've tried it at higher speeds in this configuration, but with this messy wiring, it starts to get errors once you start going above 2 megahertz or something like that. So I would expect to get at least 8 megahertz out of the commercial board once we've got it laid out properly and sorted out with correct terminations, etc. for the SPI. But for this basic prototype, as you've seen, it does work, and so that's all I need it to do. So I'm going to go and put this back in the car very shortly, and hopefully I've got some stuff to deliver, and hopefully be able to get a reasonable test run today and see how it works, and then I'll keep working on the software while the printed circuit board is being laid out. Working with a colleague from the US who I've worked with before. Nice chap, and I've met him a couple of times, and he's going to be laying out the circuit board for us and then we obviously have to get it manufactured, probably in the Far East, but not necessarily, maybe in the UK if I can find a firm that's competitive. And as I mentioned before, I'll probably get 10 or 20 made in the first instance, and they will be available hopefully in due course. I mean, if you wanted to, the schematic is pretty much available. You could knock one up if you really wanted to have a go and make a rat's nest configuration of your own, but the SPI bus is a bit fussy, and I wouldn't want to guarantee that it worked if you try to knock up your own homebrew one. It's probably best to wait until the commercial one is available, and we'll go from there. So obviously this is massive, this box. This is the same size as the IPU interceptor box which you saw earlier, but this can all be squashed down. I would imagine the production PCB is going to be like a third of this size, if that big, and it will go in a commercial box, and it will be designed to mount somewhere within reach of the driver at the front, because it, as I say, it will have 3 buttons on it as well, and a couple of LEDs for menu operations for the video, for the screen, rather than the joystick, which is basically just going to be devoted to manual control. So this won't be used to sort of select options and stuff. Probably it will just use the buttons on the front of the unit to do that. So that's where we are. It's all still coming along, and hopefully going to put this back in the car shortly, and we'll see if it works all right.